apt observation on what conclusion could be derived from the occultation jig video I was showing, or that Alan showed on Celestial Update XXI5 IV, which I'm pretty sure is French for 33 1/3. So we're going to have to add some refraction medium here. And we will put this peg here, we'll line it up with this hole here. Here's an overview of the setup. So we've got our point source light here. We have our physical occultation peg. We have another peg over here just to line everything up with the observer, and so we can use our measure stick later as well. This would represent our true star location, since we have a bird's eye view of the whole situation. We know where this true star actually is. For the Self Theo, we would be using a mathematically derived true star position based on 360 degrees circle over a 24-hour period, and from there you can generate angles, and those angles would be associated with a timestamp. So we'll rotate the refractive medium, and you can see as it's rotated, our point source light starts to shift. And we'll jump over real quick to Desmos here, so we can kind of get another view of what's going on here. Yeah, Desmos, so this is all to scale. It's all in meters. This is globular Earth down here, using globular Earth measurements and dimensions for radius. You can see also that I've added a celestial navigation section here. But if we can get into here, and here is the celestial sphere. It's about 10,000 meters. What is it? 10,000. Yeah, 10,000 kilometers out. So basically like infinite. And we have our true star, which is yeah, like it's that mathematically derived true star location. And we'll zoom out and back in to our mountain peak under question. So here we go. So here's our apparent star. So this would be this essentially. So now our parent star has moved from the true star location, and you can see you get. And then what we're doing here is we're moving our point source light until we can't see it anymore. And once we can't see anymore, we pop off our refractive medium, put our little peg back in there at the same location as the peg that was in the refractive medium. Put on our measure stick there, and we can see that this location has changed. So our true star location is now moved, and this is because there's a physical light path from our point source light to our observer. And if we have a refracted medium in there, our path would be kind of like from here down to here in like the atmospheric celestial model. Here we're kind of using a boundary layer refraction, but it serves the same purpose. It's just to show that this is basically showing that we need, in order to physically block the light, you need something physical to block it. And then you can see here, so here's our parent star, and this is the parent star's light path essentially, and that comes, and that's all the way, so it's a curvy line, just a regression model plotted between observer location and the parent star location, all the way back up to, you can kind of see it's taken a bendy path. This is the way they draw it or this is the way I've seen it drawn in other refractive, like celestial refraction descriptions and stuff. So anyway, there it is. So this is the light path that's being physically occluded. Okay, so let's go back here. Takes a bit to scroll. Got quite a bit of meters to zoom in on. And we'll just have a quick look at here just to show the difference between what an unrefracted or a star with little refraction would look like. So basically no refraction medium. Let's see here. Yeah, so here we are, no refraction medium, pulling our point source light, and it gets blocked by the pig, just like it was getting blocked by the pig in the refracted medium. And we put our measure stick here, and it's lined up pretty close to that, compared to this guy here. Okay, so we've established that there is a difference between a unrefracted or a less refracted light source versus a heavily refracted light source, and that a physical pathway must be blocked in order to not see that light source anymore. So what are the ramifications of that? So we have sidereal time, which is basically, it can almost be thought of as time. I think it's time, basically, like everything's kind of reference to the movement of the stars. It's like having a giant clock in the sky. Sorry, just checking my notes. And then we can go back here, we can talk about this a little bit. So we have our apparent star. So this apparent star is the true star position, so our mathematically derived true star position plus astro refraction. And this number here is calculated using a Bennett type astro refraction formula. We've got pressure, like observer elevation and pressure effects kicking in there, temperature, and so that's kind of adjusted to modify the raw value of the refraction. You can kind of see it being affected by temperature. Same with elevation. I've got the elevation locked in right now, so can't show you that. But so we've got the parent star here, and then we've got our true star here, and let's see, we'll get rid of, we'll move this out of here so we can see. Right here is our measured star. So this is 25569, and that is derived from stellarium. So January the 27th of 2025, Mike recorded at 6 o'clock, 43 minutes past and 7 seconds. 39 Aquarii was occulted by Pike's Peak. And I think it might actually be this guy. So you can see right here, here's 39 Aquarii and book. So right at that time stamp is when we're going to record our occultation, and that comes out to this angle here, 233, 2 degrees, 33 minutes, and 14 arc seconds. If you do the conversion, it's 255, 2 degrees, 55, 2 degrees, 0.5569 decimal degrees. And you can see we've got, and since angles equal time, our delta from measured is 0 because we're right on the measured. So let's go have a look at what our planar prediction looks like. So here we're still looking at our measured star, and everything's going to be relative to this measured measured star. So we have the geometrically formulated flat Earth planar peak is 11 seconds off, and this could be some refraction, could be timing errors, could be anything. Could be like something on the mountain. You're hitting somewhere else on the mountain, not quite where you should be hitting. Whatever. This is some errors in here. And then if we move down to so you can see that the flat Earth prediction is only off by 11 seconds there. So we have another spot where we could have an occultation. And I call this like a hybrid Earth. So this would be kind of a combination of the two models. So here we have a true star location corresponding with the globular peak, but it would be the refracted star getting occluded. So this would be the light path here. So, but in order for that to be true or measured, we would need 66 more seconds. So you got 6 o'clock here, 43 minutes, 7 seconds. Add another minute and 6 seconds to that, and that. So if this was the case, we would be getting a measurement of 6:44 and 13 seconds. Okay, and then let's go to the globular prediction. So now, with the globe, they say that we have a certain amount of refraction, and this is why the stars linger on the horizon, and they lift the stars up. And what you'll see is for that to be true, the true star will have had to travel an extra 121 real world seconds, which is like 2 minutes. So for us to get this measurement here, it would have been 6 o'clock and 45 minutes and 8 seconds. and Alan would be a glober. We'd be fighting Alan in the trenches. So hopefully that makes sense. So this is why no globe proponent will ever mention the peak as a valid location to measure star angles from, even though it is a blatant straw man of the self-theo method to do anything otherwise. The geometric peak is the unrefracted, mathematically derived crosshairs that physically intercepts the star's light path in both models. Too many conclusions can be drawn and debates ended using the physical mountain peak location to measure star angles. Therefore, the peak's location can never be uttered by our globular-minded friends. And then so some more thorough and like a mathematical analysis of the self-theo method, I would recommend going through this one. This is written by Dr. Mike Heffron, Death of the Globe Myth. And then also this one's kind of supplementary to this one. So you get all the math. This one kind of walks through the logic behind it, and this one shows you all the math behind it. And you would also like, you would go through which one is it? Might be this one. Oh, no, here it is. Open. Why is it not open? Oh my gosh. There we go. And you go through there, and here I tried my best to use all the same terms that Mike used in this document, so it's easier to follow along. Anyway, that's for a deep dive. So I hope that helps, and yeah, if you have any more questions or comments, feel free to throw them out there. Okay, thanks.